Yes, hello children. Welcome back to Chemistry Wala classes. This is Satish Kumar. Today we are going to discuss about electron affinity topic from classification of elements and a periodic table lesson. So first of all, what is the definition of electron affinity? Very simple definition I have given here. The amount of energy released when we add electron to the neutral gaseous atom valency shell is called electron affinity. It means that you have an atom. So this is the atom. So when you add electron to the valency shell of the neutral gaseous atom, some amount of energy releases outside. That energy is called electron affinity. So the amount of energy released when we add electron to the neutral gaseous atom valency shell is called electron affinity. Another name also there, electron gain enthalpy. Electron affinity as well as electron gain enthalpy, both are same. So here X is the neutral gaseous atom. I am adding one electron to the neutral gaseous atom X. Then the X is becoming X minus 1. It means uni-negative ion. Uni-negative ion. And here EA1, nothing but first electron affinity. Some amount of energy releases when you add electron to the neutral gaseous atom valency shell. That some amount of energy I am showing with EA1 here, because you added first electron to the neutral gaseous atom, so you can show with EA1. And here I have written, when you add electron to the neutral gaseous atom, some amount of energy is releasing. So the reaction is called exothermic, because energy is liberating outside. So you can call adding electron to the neutral gaseous atom is always exothermic. And the value you will get here negative. Negative means, for example, I am taking here chlorine, I am adding electron, the chlorine became Cl minus 1 chloride, and here how much energy is releasing outside? Minus 349 kilojoule per mole. So the value is minus 349. That is why I am calling electron affinity values you will get in negative manner. And the energy is releasing outside, so you can call exothermic reaction. So this is about EA1. You are adding first electron to the neutral gaseous atom. Then same you have EA2, second electron affinity also. So you need to take X minus 1. X minus 1 nothing but uni-negative ion. So you are taking uni-negative ion and you are adding one more electron to the uni-negative ion. Then you are getting X minus 2. It is known as a di-negative ion. And here also some amount of energy is releasing, but very less, negligible. So here I have written second electron affinity is always endothermic, maximum endothermic. Endothermic means you need to give some amount of energy extra. If you want to add electron to the uni-negative ion, you need to supply some amount of energy. Then only the uni-negative ion will take one more electron and convert into X minus 2 di-negative ion. That is why second electron affinity values always in positive. Here I need to add one electron to the Cl minus 1 ion, but the energy I am showing here plus 229. It means I need to supply energy in this process. So second electron affinity always endothermic. You can write EA1 is exothermic, EA2 is endothermic. In the EA1 energy releases, in the EA2 you need to supply energy. And very important question you have, 2 marks or 4 marks for board exams, class 10th and intermediate. Always second electron affinity is lesser than first electron affinity. Why? EA2 lesser than EA1. Why? Very simple, children. In second electron affinity process, electron repulsions are there. So due to these repulsions, very less amount of energy releases. Otherwise you can or you need to supply energy to add one more electron in the second electron affinity process. You can see here in EA2 process, electron repulsions are present. It means that already added electron and newly adding electron between repulsions are present. To overcome these repulsions, some amount of energy is utilized from the energy which can be released in EA2 process. What is the meaning of this? For example, here I am taking Cl, neutral gaseous atom. I added one electron, then it is becoming Cl minus 1, uni-negative ion, EA1. So here, for example, 349 kilojoule per mole energy is released. It is very clear process. Cl, neutral gaseous atom, easily takes electron and convert into Cl minus 1. This is EA1, first electron affinity process. If you want to add one more electron, nothing but EA2, second electron affinity process, then you need to take Cl minus 1, uni-negative ion, and you are adding electron, then hardly it will become Cl minus 2. Very less amount of energy or negligible. You need to supply energy sometimes. So in the Cl minus 1, here minus 1 indicate added electron already, and you are adding one more electron. This E minus is called adding electron. This is adding electron, and here minus 1 indicate added electron. So added electron, adding electron, between repulsions are there because minus electron repulsions are there. So to overcome this electron repulsions, we need to supply energy. Then only the Cl minus 1 will become Cl minus 2. That is why EA2 always endothermic. So always you remember, children, why EA2 lesser than EA1? You need to answer in single sentence. That is, in the EA2 process, electron repulsions are present. To overcome these repulsions, you need to supply energy. So EA2 is endothermic, EA1 is exothermic. And here I have written already, in the chlorine first electron affinity process, minus 349 kilojoule per mole energy is releasing out. But in the chlorine second electron affinity process, you can check here, plus 229 kilojoule per mole. It means you need to supply this amount of energy to add electron to the Cl minus 1. So very important. Next, what are the factors affect the electron affinity? So I have written first of all atomic radius, nuclear charge, electron configuration. We will discuss one by one. First one, atomic radius. So already in the previous video we discussed atomic radius. The distance between the center of the nucleus to valency shell. So this is atomic radius. Distance between the center of the nucleus to valency shell is called atomic radius. You have one small atom and as well as one large atom. So smaller atom nothing but, for example, fluorine. Larger atom nothing but, for example, bromine. 9 atomic number, 35 atomic number. So very simple, children. Smaller atom easily takes the electron. smaller atoms easily takes the electrons when you compare with larger atom. Larger atom means like this. Why? What is the reason? In the larger atom, the nucleus is far away from the valency shell. So the larger atom cannot take electron easily because the nucleus concentration is less on the valency shell. So larger atom cannot take electron easily and cannot form anions easily. It means when you add electron to the large atom, you are adding electron to the large atom, so less electron affinity releases, nothing but less energy releases outside when you add electron to the larger atom. And when you add smaller atom, you are taking small atom and adding electron, it can form anion easily, and a high electron affinity, high amount of energy releases outside. Why? In the smaller atom, the nucleus is very close to the valency shell. In the larger atom, the nucleus is far away from the valency shell. So smaller atom nucleus easily grab the electrons, but larger atom nucleus cannot grab the electron easily. So always you remember, when atomic radius increases, electron affinity decreases. When atomic radius decreases, electron affinity increases. So here I have given the relation indirectly proportional, nothing but inversely proportional. Atomic radius inversely proportional with electron affinity. Just now I said that smaller atom, larger atom difference. And next, nuclear charge. Yesterday we have discussed already nuclear charge. What is the meaning of nuclear charge? Nuclear charge is nothing but when you take an atom that contains nucleus, the energy of the nucleus depend on number of protons. In the nucleus, the number of protons are more, the energy of the nucleus is very high, and the proton number is less in the nucleus. For example, in the nucleus the protons are less, then the energy of the nucleus also less. So nuclear charge is nothing but number of protons in the nucleus. So very simple example, I am taking chlorine and as well as sulfur, atomic number 17, atomic number 16. So chlorine is having 17 protons, sulfur is having 16 protons. So where the nuclear charge is more? Chlorine, because it is having 17 protons, sulfur is having just 16 protons. So chlorine nucleus is stronger than sulfur. So when you add electron to the chlorine as well as sulfur, chlorine easily take the electron when you compare with sulfur, because chlorine nucleus is very strong because 17 protons, sulfur nucleus is just 16 protons, less energetic than chlorine. So you need to understand, when number of protons are more in the nucleus, that nucleus is energetic, and that atom takes electron easily and a high electron affinity when you compare with the atom which contains less protons. So here chlorine electron affinity more than sulfur due to the reason nuclear charge. So nuclear charge directly proportional to electron affinity. When nuclear charge increases, electron affinity increases. When nuclear charge decreases, electron affinity decreases. And next, last but not least, electron configuration. Electron configuration, two types already we discussed. Electron configuration, one is half-filled configuration, second one is full-filled configuration. Half-filled means P3, D5, F7. Fulfilled means P6, D10, F14. So when we add electron to the half-filled or fulfilled electron configuration having atoms, there very less energy releases outside. It means electron affinity is less. When you add electron to the half-filled electron configuration atoms or fulfilled electron configuration atoms, a very less amount of energy releases. It means that atom contains very less electron affinity. For example, nitrogen 1s2, 2s2, 2p3. Nitrogen is having half filled p3, and if you take oxygen 1s2, 2s2, 2p4. So here no half filled, no full filled for oxygen. If you add electron to the nitrogen and as well as oxygen grab the electron easily because it does not contain, it is not having either half filled or full filled. So oxygen easily takes the electron and releases more energy outside when you compare with nitrogen, because nitrogen is having p3 half filled electron configuration. So nitrogen cannot take electron easily, and when you add electron to the nitrogen, very less amount of energy releases outside. So oxygen electron affinity more than nitrogen, because nitrogen is having half filled configuration, oxygen is not having either half filled or full filled. So very important point. And next, here I want to tell you one note. The note is very important point. Second period elements show less electron affinity values than third period elements. So what are the second and third period elements? Second period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Third period, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. So these are the second period and third period elements. What I am telling here, second period elements electron affinity values are lesser than the third period element electron affinity values. How? Just now I have given the answer. If you see the second period element fluorine and third period element chlorine. So in the fluorine and chlorine electron affinity is more than the fluorine. Chlorine 340 minus 349 kilojoule mole inverse, nothing but kilojoule per mole, and fluorine minus 348 kilojoule per mole. So what is the reason why the chlorine electron affinity more than the fluorine? Very simple. Fluorine atomic size smaller. Fluorine atomic size smaller than chlorine. In the fluorine, more electron repulsions are present when you compare with chlorine. In the chlorine, electron repulsions are less, but in the fluorine, electron repulsions are more. So due to the reason, chlorine electron affinity is more than the fluorine. So in the periodic table, highest electron affinity showing element is chlorine, and the final touch is how these electron affinity values change in the group and as well as period. I have given you in the group top to bottom, electron affinity decreases because atomic size increases. For example, you have small atom here. It is a small atom. It is the large atom. So which one take electron easily? Smaller atom. Because in the smaller atom, the nucleus is very close to the valency shell. So the smaller atom easily grab the electron. But if you take the larger atom, the nucleus is far away from the valency shell, so it cannot take electron easily. That is why in the group, when you move top to bottom in the group, electron affinity values decreases because atomic size increases. When atom is big, it cannot take electron easily, and very less energy releases outside if it takes electron. And while moving period left to right, electron affinity values increases because atomic size decreases. In the period element to element, the size of the atom decreases. Then electron affinity values increases because atomic size decreasing, the nucleus is coming close to the valency shell. Then smaller atom easily takes the electrons. So in the period, electron affinity increases. In the group, electron affinity decreases. I hope you got the complete picture about electron affinity. So if you get any doubt while watching the video, go back and watch carefully. If you have any doubt, just give me a comment. Thank you. Have a nice day.